So here's number 33. Really quick rundown. If we were to ask, is this a geometric series? The answer is no, can't use that. If I took the nth, the limit as n approaches infinity of the nth term, we're going to end up getting 0. So the nth term for divergence doesn't tell you anything. We could use a ratio test, but I think what we probably want to do is now let's do it two ways. Let's do the ratio test, and we'll also do the direct comparison test. If we do the ratio test, we'll find out what is the value of the limit as n goes to infinity of the n plus 1 term multiplied by the reciprocal of the nth term if we do that, between these two, we're going to end up with a 2 on the top. Between these two, we have a 3n plus 1 on top and a 3n plus 1 on bottom. Alright, as we go to infinity, the plus 1s aren't going to matter, and it's going to just look like a 3 to the nth over to the 3 to the nth plus 1. This is going to end up resolving just to the 1 over 3. This ends up being 2/3, which is less than 1, and therefore it converges by the ratio test. Now, perhaps easier is the direct comparison test. If I compare this to the series 2/3 to the n, which is a geometric series with an absolute value of r less than 1, r being 2/3 here. So this is a convergent series. And I can say pretty easily that 2 to the n over 3 to the n plus 1 is less than or equal to 2 to the n over 3 to the n, because they have the same numerators, but the denominator here is larger than that one, so this is a smaller fraction. I can combine those two pieces of information to say that this series converges by the comparison test. Sorry, the direct comparison test. So either way, it converges.